things like that. Okay. So this was what we did for the bell ringer. All right, so as I said, we're doing three-dimensional figures. Today is a lot of vocabulary, taking a look at what those figures are, and then trying to draw them. You're not necessarily graded on your artistic ability, but you need to be able to draw something so that you can interpret what's going on there. So a lot of vocabulary today. Right, as far as terms and definitions, you'll have to see what I've got there. I think I have more than I did last chapter, but you need to add some pictures and add some explanation that makes sense to you in addition to what you see there. Three-dimensional figures are in general called solids. So solid is simply a three-dimensional shape. It can be made up of flat or curved surfaces. If it has flat surfaces, there's going to be a term for it, polyhedron. If not, it's going to have pi involved in some of its formulas. But on three-dimensional figures, every flat surface is called a face. So when we say, how many faces does it have, that's asking how many flat surfaces. If there's a curved surface, we might say there's one curved surface and there's two flat ones or something like that. An edge is a segment that is the intersection of two faces. So think about your three-dimensional shape. I've got a lot of them hanging around the room, some back behind the smart board. I'm going to grab some off the shelves and take a look at them. You live in a three-dimensional world, so it's very much necessary that you figure out what
We have to do
this.
Oh, thank God. What?
Yeah, a lot of those formulas over here will be this chapter because we're going
Oh,
to talk
that's
about.
okay. I thought we had to
certain
do those.
building up. We usually don't have time to dedicate to that unless we have some extra. I will have you try and make a little miniature kind of model.
Are we all doing final on like the last day of school?
Probably not the very last day, that's a half day, but there's possible on that Monday, we'll probably do something that is related either the cumulative or what would be the rocks. What are the absolute things that the Algebra 2 teacher said you need to know to be able to do to go on to algebra? So we might just, I'm guessing it probably will be. But as I said, that's not the best for everybody. But it probably will be that way, so I'll probably be giving it to you maybe next week sometime. We'll see. I have to kind of plan out the last few days and see. All right, an edge. An edge, as it says, is where two flat surfaces come together. So these come together, so this segment here where those connect, that's an edge. This is an edge, this is an edge. So when you go to draw a three-dimensional shape, you're drawing the edges. And some of them are dashed in the picture because you can't see it if that were solid, correct? It's there so that it helps you get the shape in mind, but you can't see it. That helps your brain interpret what's going on. If you make it all solid, it becomes more or less an optical illusion. And that's something I like to do the last part of class is show you some optical illusion type of things. So try and draw it with the dash so that your brain knows how to interpret what's going on. Okay, another term up there is vertex. A vertex is the point that is the intersection of three or more faces. So three or more faces, 1, 2, 3. These three faces come together at that corner point, that's a vertex. Again, three faces come together, that's a vertex. I also think of it as three edges coming together at the corner rather than three faces. And it says three or more faces. As you look at some of the models, let's see, the light blue one up there has 1, 2, 3, 4, 5 faces or 5 edges coming together at its vertices. So as far as the terminology, we want to probably avoid saying the word side. It's a side of the polyhedron. Now, because what do you mean by side? You mean side as in a flat surface side, a side as in the edge of the face. So side, we're gonna try and avoid saying. We're gonna say face, we're gonna say edge, we're gonna say vertex. Use the correct terminology so that we're communicating correctly. Okay. All right, as far as three-dimensional figures, these are the general categories. We have prisms, cylinders, pyramids, and cones. There are things that don't fit into these categories. But you are probably trying to draw each one of those as I'm talking about them. The first one is a prism. You're trying to draw two parallel, congruent, in this case triangles. Those are the bases. And then you connect the corners of those bases, and that visually makes the faces that go around it. And those faces are parallelograms, they might be rectangles. Depends upon whether the triangles are directly above each other or not. So before you go to the next shape, read through that definition and see if you understand what it's saying. Any prism is formed by two parallel, congruent, polygonal faces. What was a polygon? Both shape, straight sides, flat, yes. So the one you were drawing is a triangle. One of the models I grabbed from the shelf over there is, this is another prism, but what is its base? Well, two tops and bottoms. So if I hold it this way, is the rectangle the base? And then if I hold it this way, the hexagon is the base? No, it's the same shape no matter which way I hold it. So if you're trying to identify the bases, you have to connect the corresponding corners and make sure that it forms rectangles or parallelograms. So if I was thinking of it this way, notice when I would connect this corner straight down to its matching one, that's not going to make this face. So it's not the rectangles that are the bases of this, it's the hexagons. I'm going to sit it on a hexagon so that then you can see matching corners when you connect them make rectangles or parallelograms. When would it make a parallelogram? If this hexagon was slid over instead of directly above it, the sides would slant. We'll grab one of those in a little bit. So prisms have two parallel and congruent faces. When you connect the corners of them, you'll make parallelograms or rectangles. Okay, the next one down is a cylinder. Cylinder is kind of like a circular prism, but that's not what we call it because it doesn't really fit the definition. But a cylinder has two parallel and congruent circular bases. And then going around it, that's a curved surface that simply connects your two bases together. So the bases are the circles, and then the curved surface going around it to close it up. Pyramid. Pyramid has a polygonal base, and the one that they're having you draw, again, is a triangle base. I'll give you a tip. I usually draw the base first. Draw the triangle base. And then put a dot where you want that top vertex to be. They've kind of got it off to the side a little bit on this one. Then connect. If you need to, get a straight edge or edge of something to help you connect from the vertex to every corner of your base. Again, dashing so that you can get the three-dimensional in mind. So that definition again says it's formed by a polygonal base and triangular faces that meet at a common vertex. So that top point is that common vertex. Sometimes it's called the apex of the pyramid. This book just calls it the vertex of the pyramid. Pyramids are usually sitting on their base. So it's easy to identify the base and then the point that it goes up to. Then a cone is a circular base, and again, one vertex. All those edges or segments that would go up make a curved surface to finish up the cone. When you draw a cone, that base wouldn't be drawn as a perfect circle. It's drawn more as like an oval or an ellipse. So once you draw your base, put the point where you want the vertex to be and show the edges that connect. Getting some pictures that look decent. see the front row ones, I can't really see. And the dashing, the back part of that circle on the cone, it's dashed because it wouldn't really be visible. Cube is another three-dimensional shape. I think it's not in the chart, but I believe I put it just below. A cube is a, what? Is it a prism, pyramid, cone, or cylinder? It's a prism. What kind of a prism? What shape are its bases? Squares. Square-based prism is another name for a cube. Otherwise, we do have all kinds of prisms. You don't have to draw all these, but you try drawing the rectangular or the triangular prism. Rectangular prism basically is your box. I held up a hexagonal prism that was taller than the one up there, but the name of the prism is the shape of the base. So a hexagonal prism is going to have a hexagon for the two bases. That doesn't mean it's sitting on the hexagon. It could be turned differently, but the hexagon's the bases. Same thing with pyramids. The first word there before pyramid is telling what shape the base is. So a triangular pyramid is going to sit on a triangle. Where's there a triangular prism or a triangular pyramid hanging in my room? Triangular pyramid. Okay. The red one up there. Okay. What else can we find in my room? Cube. Cube is the brown. Any of those others up there? Is the gray one a prism? Or a pyramid? Yeah, it's like two pyramids put together. So you wouldn't call it a pyramid or a prism. The blue ones are definitely not prisms or pyramids. So those will have a more general name, just that they're polyhedra. Poly because of the polygon size, and then the hedron is, or hedra, so tells you that it's a three-dimensional solid. So we'll have a general term for those. And staying back behind the smartboard, those are just kind of some more just polyhedra. All right, let's have you classify the figure, name the vertices, the edges, and the bases. And I want to see how you're writing it down. So let's, if you want to do it on your paper or your marker board, I want to see how you're naming each of those correctly. So classify the figure means tell me what kind of figure it is. What's it called? Classify it. Everybody's got pentagonal pyramid. Name the vertices. What are you naming when you name the vertices? You're naming the points, like the corner points of it. You're naming the edges. You're naming the segments of it. You're naming the bases. Depends upon the shape. We don't have a symbol for pentagon. Yeah, we don't have a symbol for pentagon. We'll just list the vertices. bases does this have? There's just one base. There are multiple faces, but it's asking you just what's the base. That last thing doesn't make sense. We should have, you called it, or what did you call it? What's the name of it? So by even writing this first word, the pentagon's the base. So name the pentagon. And then you build those, and then those letters, yeah.
Do we have to put edges with a B, C, D, E, F, W, those two? I just did.
If you're naming all edges, yes. Now, edges are segments, so what symbol should you have? There should be a little segment symbol on the top of all your edges. If you don't have the segment symbol, you're not actually naming the segment, you're naming how long it is. The segment symbol should be there. Okay, so see if you did the right form on your answer. Pentagonal pyramid, the vertices, just all of those points listed. There were 6 of them. The edges, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total segments. Got the segment symbol listed there. And the bases, there's only one base. We don't really have a symbol for pentagon, so I just put A, B, C, D, E, listed the vertices going around it. You could start at whatever point you wanted, but you have to go around it. Okay, doesn't look like any questions there. Okay, so let's talk about this one. Classify it. What shape is it? You think it's a cube? Looks taller than wider, doesn't it? And I think that's distorted because of my projector. So I think they called it a cube, but I'm gonna say the way that it's looking up there, I don't think we would call it a cube. What would we call it? Okay, rectangular prism. I guess we might even argue whether it's a rectangle. I think the intention was. So when you name the vertices, how many points would you list? 8. There would be 8 total listed? Okay. When you name the edges, what are you naming when you name edges? The segments. How many would there be? 12. Okay, so since we did that on the last one, I'll just show you. There's all your edges. How about bases? You said this was a prism. How many bases does a prism have? 2. Okay, so you could name A, B, C, D, and E, F, G, H as bases. On a rectangular prism, you really could name A, B, F, E, and D, C, G, H. Those could be the bases. They're parallel and congruent, and when you connect the corners, you make the parallelogram faces. Or you could name the front, A, D, H, E with B, C, G, F. So you almost can't go wrong on naming the bases, but you'd have to pair it up correctly. Give me one pair of bases. Okay, next shape, a little bit pixelated, but what is it? Cone, correct. So what would be the vertices of the cone? Just N. M is not a vertice. It's just the center of that circle. Edges. None. Yeah, there are no edges. How about bases? And we have a symbol for circle, which was a circle with a dot inside it. That dot's really big here, but circle M. Okay, so that one was a little bit different. How about this one? Can you tell what it is? Triangular prism, correct. Okay, triangular prism. Vertices, we would list how many points? 6 total. Edges, how many edges are there? 9. 3 3 around the triangle on the top, 3 around the triangle on the bottom, 3 going up and down. And bases. The 2 triangles, could we name any of the rectangles? No, there's not a parallel one to it. We do have a symbol for triangle, so you could go triangle TUV, triangle XY, WXY. All right, seemed like you were getting that. So let's go to the next idea. On your notes, you'll find net. A net is a diagram of the surfaces of a 3-dimensional figure that can be folded to form the 3-dimensional shape. Now, as I'm going through this, I'm thinking, I didn't look for an app. There probably is an app, and if you find one, let me know what it is. That would take a net and fold it up, or take a 3-dimensional shape and unfold it to show you what the net is. I don't think I had to download an app related to that. Okay, to identify the 3-dimensional figure from a net, you have to look at how many faces there are, what shape they are, how they're arranged. So for instance, here I'm holding up a net. Look at how many faces there are and what shape they are. Okay, there's 6 squares. So what could fold up and make a 3-dimensional shape out of 6 squares? A cube. So now I need to see, is it connected correctly? Does it fold up so that every face is there and nothing is doubled up? Can't fold it very well, but yes. If I get my creases in there better. So this is a net that would create a cube. Is it the only net that would create a cube? No. But it does fold up in order to make my shape. Okay? So that's what a net is. I'll hold up a few other ones. Okay, here's a net. When you tell the shapes, I need to highlight them probably. Maybe I can hold it this way. Does that make a cube? Hold it up in your mind. These fold it around. And we've got a square there, and we've got a square there. So that was another net for a cube. How about this one? 1 square and 4 triangles. A pyramid. What kind of pyramid? What will the base be? The square would be the base. Okay? Because the triangles have to be the thing that go up in order to form the top of it. So a square-based pyramid. We don't usually say something like squarezoid. Square-based pyramid. Okay, how about this one? Hexagonal prism. See, there's no triangles on it at all, so there's no way it can make a pyramid. So hexagon, hexagon, and all these little rectangles would fold up to make the edges, kind of like a box, a hexagon box with a lid. How about this one? Triangular prism, or is it a pyramid? How many triangles would you have to make a prism? Would 2 be enough? Okay, this does make a prism. To make a pyramid, you'd have to have, probably 4 would actually be the least, because the 4 would make the red one up there. If you had a square on the bottom, we had that just a second ago, the square on the bottom, you still needed 4 triangles to go up. Alright. So you can kind of tell based upon how many there are. Let's see. What kind of prism? Okay, some are saying square, some are saying rectangular. Kind of depends which ones are the bases. If these are the bases, then I would call it a square, or could call it a square prism. But you could call any pair of opposite faces the bases. So in general, it might be better to say rectangular, because a square is a rectangle anyway. Rectangular prism. How about this one? Good. And I'm hearing cylinder and I'm hearing cone. Let's see. This to go around that circle, go straight up. That is a cone. Yeah, kind of hard to hold it. And how much of a how much of a circle this thing is that goes around it depends upon, if it's skinnier, it wouldn't be as far around. If it's flatter, you're gonna need more of the circle. So how much this is of a circle just depends upon the, the cylinder, or cone. Right, this one? Pentagonal prism, correct, folds up around there. This one? Triangular what? Triangular pyramid? Too many triangles for a triangular prism, or pyramid. Is it a prism? A prism, doesn't it have to have rectangles? This isn't triangular, but doesn't it have to have a rectangle to connect? You drew a triangular prism on your sheet. This one's not a prism or a pyramid. It does fold up to close. It's not the gray model that's up there because I don't have quite enough, but it's like two triangular pyramids together, one on top, one on the bottom. So kind of tricky. We don't have a term for it. It is a polyhedron. So it is a net, but a little bit different net. How about this one that doesn't have as many triangles? It's got the 4 triangles. Will it fold up to make the red triangular pyramid? Let's see, kind of hard to visualize. But there's 3. This triangle does fold to make the bottom. Kind of tricky. So it's easier to do like if there's a whole strip and then the 2 bases that it would wrap around. These were not too bad for you. I showed you a hexagon one where you had the box edges and then the lid. How about this one? Rectangular prism, but doesn't fold up right. So it had the right faces, but they weren't arranged in order to make a net. So that's also something you need to be careful of. One of these rectangles or squares needs to be on the other side. All right, questions on what a net is? Okay, let's see which ones they gave. So what's that one going to fold up to make? That one's a cube. Cone. Correct. Triangular pyramid, we just looked at that one, or maybe it was arranged a little different. Okay, this one would be a cylinder. The rectangle has to be the right length to wrap around the circles. So again, if you find, I'll try and search probably too, but app maybe that helps you visualize that. That would be something I'd like to put in my list. Okay, cross sections. A cross section is the intersection of a 3-dimensional figure and a plane. Recall that the intersection is the points that the figures have in common. So a cross section is a 2-dimensional figure made of common endpoints, or common points. So what we've got here is a pentagonal pyramid. We have a plane that's intersecting it horizontal to the base. The cross section is this shape right here that is formed by the plane and the 3-dimensional shape. What shape is it? It's a pentagon. Is it the same pentagon as the base? It's similar. It's the same shape, but smaller. If we had tilted the plane, it would be kind of a distorted pentagon. But being parallel to the base, it makes a similar figure, just smaller. So the cross section is a pentagon. We're describing the flat shape. Cross section of a cone and a plane, if you intersect right at the tip. What's in common? What's the cross section? 1 point. Now what would happen if that green was down a little bit further? make a circle. Further down, bigger circle, bigger circle, bigger circle. And let's see, let me grab a model that I think I have in a drawer here of what's called the conic section. Maybe a little bit. The brown wood probably have some really shells. One more place, I maybe let Mrs. Permanga use it. Okay, I'll have to get it back from her to show what that is. Okay, but I was gonna show you just all the cross sections on a cone. Okay, describe the cross section. What shape is it? Hexagon, okay? So that would be going parallel to the bases. If you would go perpendicular to the base, what if you would go this way? Let me kind of hold it this way. If I would go straight down, depending on what angle I'm going at, if I go straight down, I'm going to get a rectangle. If I go at some type of angle, I might get a trapezoid. I'm trying to think, will I get a trapezoid ever? I think you're going to get a rectangle along there. Okay, that iCross app, you can do some cross section. So why don't we try that iCross app? Bring that up. It has 3 S's. I think maybe it was on a list at the beginning of the course that I told you to download. And you can have it give you the tutorial, I guess the steps how to do something. Is yours iCross Lite or just iCross? Yep. I've got the other one, and so I'm thinking maybe I have more shapes than what you have available. Okay, why don't we just take a cube, and you can do the question mark to give you tutorial tips up at the top. So that tutorial thing will help. It says you can rotate the polyhedron with your fingers, so you can take the rectangle, or the cube, and turn it around. Notice how the dashing changes as you're turning it. All right, to make a cross section, it says tap the polyhedron to set the first point. Okay? So you put a point, it puts a purple dot. Let's try and make a cross section. Purple dot, purple dot, purple dot. I have to turn it. I hit 3 corners and I created a triangle cross section. You can rotate it and see what did I intersect. So I kind of cut right through the corner. Rotate it, and some things down at the bottom. You see a flat picture down at the bottom. It will, let's see, maybe it's the other one. I'm thinking it's supposed to pull it apart. Very bottom in the middle. I'm gonna see two choices right now. Tutorial maybe is why. You can pull the points. Once you get those purple points, you can move them around. Also, you got to pull them. I think it's because I have a tutorial. But you can pull those points and see different cross sections. And you get it to be like a rectangle, maybe a triangle cross section. The choices down at the bottom, like in the middle of that bottom, will pull it apart. Then you can kind of see, when you pull it apart, what is that cross section? Everybody getting up to work and do some things? So what cross sections can you create from the cube? Everybody messing with the cube right now? I could get a triangle cross section. What else could you do? Did you get a trapezoidal? Cross section. Okay, you got a trapezoid. Are you getting like squares or rectangles? Now, you're not describing a three-dimensional shape when you describe the cross section. You're describing the flat thing. And you might go on to try some other shapes besides the cube. What all do you have? Square pyramid, pentagonal prism, and then you've got some things that we didn't really name yet. Icosahedron, that's the light blue one up here. You can see what some cross sections would be based on that. The normal iCross has more choices, but I don't know if you want to purchase it or not. But it's kind of cool program to mess with. And you tried the square pyramid. What all can you create for a cross section on a square pyramid? If you haven't messed with a square pyramid, maybe go back to that shape. Square pyramid. What all can you make? How would you create squares as a cross section for a square pyramid? Parallel to the base. You could create triangles. Square pyramid. On some of the problems on your homework, you'll have to describe how would you intersect it, or how would you make the cross section in order to get a certain shape. So you might use some terminology like intersect parallel to the base or perpendicular to the base. You might say add a diagonal or add a slant to the base. Are you understanding cross sections? I don't think it gave us a cone as an option, did it? I've got a picture on the smartboard of a cone. If you slice that direction on the cone, what shape is it going to create? That would be a triangle, as long as you go right through that top point. How about this question? A piece of cheese is a prism with equilateral triangular bases. I don't know if they give you that choice. It doesn't look like it. Equilateral triangle bases. How can you slice the cheese to make equilateral triangle shape for the cross section? How would you slice it? I'll let you get back to that cross in a little bit. Let's finish up our lesson. Okay, so here's a piece of cheese. Equilateral triangle prism. How can you slice it so that you have equilateral cross sections? You can't just say that way. So describe, because if I held it this way, going up and down wouldn't do it. So to the base, parallel to the base. Which faces are the bases? The triangles, okay. So if you sliced parallel to the triangles, would you get equilateral triangle cross sections? Okay, yes, so that would be how to describe it, to go parallel to the bases. How about if you sliced making rectangle cross sections? How could you get rectangle cross sections? Okay. Parallel to a face. Parallel to the rectangle faces. Okay, which could also be described as perpendicular to the bases, perpendicular to the triangles. Correct. So you're going to get rectangles, small skinny ones, more squarish, and then longer the other direction. So you might refer to the bases parallel or perpendicular. This I thought was interesting. It was in our books on page 654. They have watermelons that are cube-shaped. Why would you make a watermelon cube-shaped?
So you could put these
Stack them easier, transport them easier, put them in a refrigerator easier. They don't take up near as much space, that type of thing. So if you wanted triangular faces, how would you cut that watermelon?
like.
Okay, kind of cut it, two diagonals, so you're cutting all the way through,
Yeah.
and then you're making these? Okay. And I guess it didn't really ask with one slice. It was thinking one slice, it really meant cross-section, so I'll have to change that wording. So if you cut kind of catty corner through the corner, you would make triangular faces. But I agree with what you were thinking too. I have to change the wording on that. Okay, so our lesson was on naming them, doing the nets, and doing the cross sections. You might want to play with that I cross some more. Here's a fun kind of cross section activity. So before we work on homework, let's see if you can name some candy bars. Show you the cross section of a candy bar. Yep. You need to name, okay, got the assignment on the back. Okay. All right, name the candy bars. What candy bar can you identify by its cross section? Dalton?
That very bottom left corner one, that's the one with the roller thing.
A Rolo? It is a Rolo, correct. Sam?
Top far right one.
Kit Kat? Correct. Are you naming your favorites here? Jack?
The top far left, I think that's like
Almond Joy?
or
Yep, Almond Joy. Okay, Chili.
Is the third one on the top from the left, is that Butterfinger?
Butterfinger?
Is that
It was. Maybe even a peanut Butterfinger possibly. Okay, Dalton again?
Bottom right hand corner is a payday.
Peanut nut roll, which it could be, is that the same thing? Is Payday,
Yeah.
Payday doesn't have chocolate on the outside, does it? So it's probably just the company that put this out, this is what they call them. Okay, what else?
The second one on the bottom is
It's what? M&M's. I think their brand is Smarties. But yes, that type of thing. Okay, so what else? Top row, how about the second one?
mounds.
A mound or something, it looks like a lot of coconut type of stuff. Yep, mounds. This one we did, how about this one? Looks like, yeah, melty caramel in the middle of it. Like a caramel, is that what you're saying? Yeah, you're right. I know. Okay, I don't think we named this one. It's like it's got a crunchy thing, it's got more of a solid thing on top. Twix maybe?
No.
No?
Maybe Twix. Is it? Because Twix is usually like a little bit lighter and then darker and then caramel.
Okay, so maybe not that, huh?
The one to the left of the nut roll is
Okay, she switched on us. Any choices on this one? We were debating if it was a Twix or not. It says it's a Twix. It does say it's a Twix. Okay, this one you saw?
Three Musketeers.
This one's Three Musketeers?
That's what I was
Yeah,
thinking.
he's right. Okay, let's work left then. How about this one?
Coconuts.
It does kind of look light. Coconut? I don't think it's a Snickers. Mars. Never eaten a Mars. Actually, I don't think that's Snickers with that thing in the middle. I don't think Snickers has a chewy nugget or something in the middle. Baby Ruth has more of a solid in the middle. Okay, I think we got all of those, right? Okay, there are some more. One more screen. Making me hungry.
Yeah.
First one's a Snickers?
Yeah.
Yes.
That's
Milky Way?
That's a Milky Way. Oh, yeah.
It is a Milky Way.
Oh,
Would
is
you
the-
think
is
that-
the bottom, like, from the right too, is that like a crunch bar?
Oh.
Or is it something weird?
Whatchamacallit is what that one is. Jack?
The one that's next to the green thing on the left. That's probably pretty.
It kind of looks like a salted nut roll type of thing. Yep, Payday. Let's see, did we do the second one on the top? No? Ideas? It's kind of caramely on the bottom with nuts. Well, there's so many different ones, but
Is the,
they all have nuts and caramel
is
and
the bottom, the right three, is that a bottom right or left one? Is that like a toffee? Heath bar.
like a Heath bar or something. I think theirs is a score, but I think that's the same thing, basically.
Yeah, I've never heard of it.
Okay, so this one we're not sure.
No.
Oh, whatchamacallits are good.
Yeah.
A peanut butter Snickers.
Oh, that's
That's what
good.
that was. I've never eaten a peanut butter one. Okay, we did that one, I think. This one.
Probably got the
Or something. Some kind of a minty.
No, that's white.
Where's peppermint buddy? They're saying that's
Klondike bar. Yeah, that's for
everyone.
Klondike bar. Arrow.
Arrow. It says a peppermint in the middle. Okay, how about this last one on the top?
That looks like really obvious.
No? Mr. Big. I don't know that I've had a Mr. Big. I don't know if we can buy those around here. Bottom row,
Nutty bar.
nutty bar, I don't know, if that doesn't look real nutty. Kind of reminds me of a Twix, but it's taller.
Oh, isn't it those,
Yeah. I literally had one of those yesterday, it looks like, I know what it has to be.
What did you have yesterday?
Coffee.
What? Coffee crisp is what that one was. I don't think I've had a coffee crisp. This one? It looks like crunchy. Crunchy things. Okay, that one is a, 100 grams. Okay, did we name this one? I think that's our last one. A different kind of Snickers?
Snickers dark.
Yeah.
So I'm comparing these two Snickers. One has the caramely thing on the top and one on the bottom. This one says, "Oh, Henry."
What?
Wait. What was the last one?
The last one on this row? Did we not do that one? Barn.
What?
See, there's a few there that I don't know that we have around this area very much. Stores, or maybe they were an old one that's not made anymore. I think we got through all of them. Made ourselves hungry. But the idea of a cross-section is something that you do in real life. All right, so your assignment. Okay, finish up the cumulative list, those 1 through 9, the chapters on the back of that worksheet. And this assignment part will probably go pretty quick. A lot of it is naming what the 3D shape is. We did some where you listed the vertices, faces, edges, bases.